device that in that another sub concept is the third way is that interrupt nesting. So so far we have seen that we'll be having this interrupt request lines and interrupt acknowledge lines. From interrupt request line, the interrupt request is been raised and that signal will be passed to processor. If it is accepted through the INTA line, it will like notify. So here what we have is we will be having here multiple lines, these lines. So we will be having multiple INTR line and multiple INTA line, and each line will have a different priority. Okay, higher to lower like that. So each will have different priority, and here each what to see here. So priority level of the processor. So we will be having the processor, right? So all these lines are connected to the processor. So from one way we will be having INT line, from another way from the processor the INT lines are going. So once you see that diagram, it should be easy for you to understand. I will be showing the diagram. So now let's let us read this first. So a multiple priority scheme is implemented by using separate INTR and INTA lines for each device. Each INTR line is assigned with different priority. Priority level of processor is equal to the priority of the program that that is currently being executed. So the whatever the program is being executed in the processor, the processor will have that priority. Suppose there are like 4 to 5 programs. So first so the program is being executed is nothing but having 10 priority, like suppose we will see greater number will have more priority here, example. So that program will have 10 priority. Suppose suddenly in the processor we receive another program which is having like 15 priority, so it is higher, right? So this program it will be halted and that program will be like executed first, like that. So that means, so that's what it means. So now the priority of the processor, earlier it was 10, which is equal to the program which is executing. Now it will become 15 since the program which is executing is 15. Okay. Now for some device, what happens now? The same thing here for some device. So what happens? Like I said, 10 priority was the program which is being executed. Now suddenly 15 priority ka program comes. So sometimes what happens now? What does this processor does? It will increase the priority of the program which it's currently being executing. Okay. So suppose it was executing this 10 priority ka program. Now what it will do, if it receives some 15 kadu, not necessarily it will receive some higher priority process itself. Sometimes what it does, in advance also what it does, it will increase the priority of this program such that if any other program comes which has equal priority or lower, it will disable that from the device, it will disable that request and won't execute that thing. So that's what it has written. For some device at the time of execution of ISR, the priority of the processor is raised to that of the device such that the interrupt from devices at same priority level or lower are disabled. Suppose interrupt had come but it didn't started responding to the interrupt, suddenly that higher priority device ka interrupt will come. So what will do, it will raise this currently being executed program's priority to that of the device's priority such that it will become equal priority na. So if it is equal or less, it will disable that. Okay, understood. So now we will see here this diagram. So as you can see from this diagram, we have multiple INTR line. So from 1 to P we have, then INTA from 1 to P we have, and here this is a processor and device 1, device 2, so on up to device P. So here what we have, here this extra thing if they are separately. Okay, privileged instruction and privileged exception. So what is this privileged instruction? So let us read first. Processor's priority is encoded in a few bits of PS word. So whatever the priority is na, so it is encoded in some bits. So that encoded bits can be changed. So what we had discussed last time. So sometimes it will increase the priority, right? So that bits can be changed only by the privileged instructions which can write into this PS. Okay, PS. So now this instruction can only be executed if the process is